Hello and good morning. This is Teacher Francis Omai. Welcome to my YouTube channel. And in my discussion today, I want to discuss about equations of a straight line together with gradient and gradient. And maybe to start with, I'm gonna focus on the key things that we need to know in this topic, equation of a straight line and gradient. And number one, we talk about gradient. And what is gradient? When we talk about the gradient, we talk about the slope, or in other words, it is the change in y over the change in x, the change in y over the change in x. If you're given some coordinates of two different points usually give a line, a straight line, and this one leads to the gradient or the slope, or in other words, we can say y1 minus y2 over x1 minus x2. We shall do with an example and see how this works. Now, for us to get the gradient, we either need, number one, we will need 2 points, say A with A, B, and say B with again A, B, or we can call them C and D, so that this one is y1 minus y2 and x1 minus x2. Number two, we will also, if we don't have 2 points, then we need to have maybe an equation of that line, because an equation given in the form of y is equals to mx plus c. The value of m here is the gradient. This one is the gradient, and that means this will be our change of y over change of x. That is it. Now, equation of a straight line is given in the form y is equals to mx plus c, and here this one is the y intercept. Shall come to that. This one is the value of x. This one here is the gradient, and again this one here is the value of y. With that is the equation of a straight line. It can also be given, can say, or it can also be given in the form of ax plus by plus c is equal to 0, and in this case a, b, and c are constants. Sometimes equation of a straight line is also given in double intercept form, which is this one is what now we call double intercept form, whereby we have we have x over a plus b over y over b, rather y over b is equal to c. This one is what we call the double intercept form. Now, after knowing all this, we'll be looking at other aspect of equation of a straight line and gradient, and the other aspects include, number one, we have y Now we are in number 2. Number 1 was gradient. Number 2 is y-intercept and x-intercept. With y-intercept, we say at y-intercept, maybe I can draw a Cartesian plane so that it is very easy for us to understand. Now, student, if you want to know where y-intercept and x-intercept is, this one is the y-axis and this one is the x-axis. Now, a point say Q, where the line cuts the x-axis is what we call the x-intercept. And at this point, the value of y is equal to 0. Now, another point here, call it point P. This one is the y-intercept, a point where the line cuts the y-axis. And at this point, we say that the value of x is equal to 0. If you are to read the coordinates at this point, the value of y will be equal to 0. Now, that is the x-intercept and the y-intercept. We normally get them in form of coordinates. We shall be doing that using an example when it comes to elaboration of all these. The other point is about parallel and perpendicular lines. Now, about parallel and perpendicular lines, we say that if two lines are parallel, they can never meet. And at this point, if this one is M1 and this one is M2, I mean gradient, the gradient of line 1 and the gradient of line 2, M1 is equal to M2 at that is when the lines are parallel. Now, when the lines are perpendicular, it means the line cuts each other at an angle of 90 degrees. So if this one is L1 and this one is L2, the product of the gradients M1 multiplied by M2 usually give us -1. Sometimes I normally advise the student, if you want to easily know the gradient of the other line given one of the lines, we normally say that it is the negative of the reciprocal of the first gradient. Now, that one is perpendicular lines and parallel lines. The second last point on equations of a straight line is about intersecting lines. Now, if two lines are to intersect, say this one is L1, this one is L2, we normally have a point, say a point M, and at this point M is the intersecting point, whereby say the first equation is y1 is equals to mx plus c, and say y2 is also given in form of y2 is equals to mx plus c. Now, in this case, we normally say at the point of intersection, at the point M, which is the point of intersection, we normally say that y1 is equal to y2, and therefore we'll just pick this part here, call it 1, and equate to this part here, call it 2. That means 1 is equal to 2. Again, we'll be doing that using an example such that it will be easy for us to understand easily. This one is number 4. Number 5, and the last thing we look at in this part is about angles made by a line and angle made by a line and y or x axis. Now if we have a line passing, this one is the y axis, this one is the x axis. If this one is our line, there is an angle made here, and we also have an angle made here. This one is an angle made by the line and the y axis, and this one is the angle made by the line and the x axis. Now using trigonometric ratios, that is sine, cos and tangent, we talk of SOHCAHTOA. If we talk of SOHCAHTOA, we normally base our argument on this part, tan. If you want this angle, then we'll be talking about change in x and y, and the change in y over the change in x is giving us this trigonometric ratio called tan. With that, we normally talk of tan inverse. Tan inverse of gradient is the angle made by a line and the x axis. Now if this one is our angle theta, this one is 90 minus theta, and that means 90 minus tan inverse of gradient. Tan inverse of gradient, this one gives us angle made by a line and the y axis and the y axis. I think that's all about equation of a straight line. See me in the next video where I'll be doing some of the examples. Thank you for watching. Remember to subscribe and share Teacher Francis Wamae YouTube channel. God bless you. Thank you.